Hello, this is my video example for chapter 10, number 86. So this one says a 50-gram ball of clay traveling at 6.5 meters per second hits and sticks to a 1 kilogram block sitting at rest on a frictionless surface. Part A, what is the speed of the block after the collision? Part B, show the mechanical energy is not conserved in this collision. What is the percentage of the ball's kinetic energy is lost? Where did this kinetic energy go? Useful way to look at this is in this page. This page is number 39. And this page talks about two trains colliding into each other. So this is the initial velocity, or this is the velocity when these trains are traveling. This one is traveling at 1.5. This one is negative 1.1. So this one's going left, that means it's going negative. This one is going right, it's positive. So after when they collide, here's the new velocity at negative 0.25 going to the left. And here shows the formulas of solving for kinetic energy, which is all that. And then we have another kinetic energy. This one is the initial, this one is the final. And then this is the equation for thermal energy. So first thing we want to do is momentum. We want to solve momentum because it's the speed. And what we know here is the M1, M2, V1, and V2, which is involved with momentum. This is the equation. So this is the mass for the object 1, and this is the mass for object 2. So in this equation, we take the first object, which is the balls, the speed and the mass together, plus the speed and the mass for the block, and equal that to the mass of the first object plus the second object, and find V3. So we want to find V of 3, so we plug in the numbers from here, which is labeled right there. We plug it in and we would get this. This is 325 grams times meter per second grams divided by 1,550 grams. We got that from adding that, and so when we divide, we have 2 grams right here. These grams cancel out. They cancel out, which turns into this simplest form, 13/42 meters per second. And next thing we want to look at is we want to look at kinetic energy. We talked about this during class, and for this, we need to find the initial and final kinetic energy. So the initial kinetic energy, this is an equation that we're all familiar with. So we take 1/2 of the first object's mass times the velocity squared plus the same thing except for the second object. So we plug in the same numbers again in here, and we would get 1,056.25 grams per meters squared and second squared. So this is what we would get if we were to do the initial kinetic energy. And for the final kinetic energy, we would need to use the different equation. So this is for kinetic, that's initial. This is for final. For final, we take 1/2 of the first object minus the second object and multiply that by the velocity, or V of x, Vx squared, which is the velocity's final. So here we plug in the numbers, and for this is basically V3. So we got this, from up here, V3, which is Vx. So we plug that in also, and we would get a total of 50.9 or 297 right here. So this mechanical energy is not conserved because the initial kinetic energy is not equal. I mean, the initial energy and the kinetic energy is not equal. So these two numbers should be equal. The initial and the kinetic final should be equal, which this shows as not equal. And lastly, we're going to look at mechanical energy. Mechanical energy comes from kinetic energy plus potential energy. And for mechanical energy, we have to solve for the percentage. So here we talked about show that the mechanical energy is conserved, so we show that this is not conserved. And for this part, what percentage is lost, we find it through this equation here. So the kinetic energy, that's the final minus the initial divided by the initial. So we do that here, we divide it by that, and we get negative 0.952, which is 95.2% energy loss. And this energy loss changed into thermal energy when the ball collided with the block. And whenever something contacts with something else, for example, in this case, whenever the ball contacts something, it creates thermal energy, similar to when you're hitting a nail with a hammer. And that's it. This is question number 86 for chapter 10 about energy. Thanks.